Hello everyone and welcome back to Math 143 Finite Mathematics. Today we begin chapter 5 Mathematics of Finance. So this chapter is different from the previous chapters because we will focus on financial applications rather than matrices or linear programming. Every day people borrow money, invest money, open savings accounts, take out car loans, and buy homes. All of this involves interest. Today, we will answer questions like how much money will my investment grow to? How much interest will I earn? What is the difference between simple interest and compound interest? So, by the end of today's lecture, you will be able to solve all of these types of problems. So, by the end of today's lecture, you should be able to define financial terminology, calculate simple interest, find accumulated amount using simple interest, calculate compound interest, also solve compound interest problems involving different compounding periods. Okay, first of all, what is an interest? What is interest? Okay, let's begin with a very simple question. What is interest? So, interest is either the cost of borrowing money or the reward for investing money. Interest is either the cost of borrowing money or the reward for investing money, right? So let's think about two situations. Suppose you borrow money from a bank to buy a car. The bank lets you use its money, but in return you must pay interest. Now, suppose instead you deposit money into savings account. Now the bank is using your money, so it pays you interest. In both situations, interest is being paid. The only difference is who receive it. Okay, so let's move forward to see the financial vocabulary. Okay, so before we start solving problems, let's learn some important financial terms. So first one is the principal amount. Or principal. The principal which denoted by P is the original amount of money invested or borrowed. The original amount of money invested or borrowed. Let's see the example. As of the example, if you deposit $2,000 into a savings account, so the principal is $2,000. $2,000. Okay. So then next, let's see the next one, interest. So the interest is the extra money earned or paid, which we denoted by using I. The extra money earned or paid. Next, accumulated amount. The accumulated amount, which we denoted by uppercase letter A, which is the total amount after interest has been added. After interest has been added. Next one, the next term is interest rate. So the interest rate, for the formulas, we will use that interest rate as lower case letter simple r. So the annual interest rate tells us how quickly money grows. So the annual interest rate tells us how quickly money grows, right? For an example, let's see the example. Let's say the interest rate are 5% per annum. That means $5 of interest for every $100 each year. 5% per year. Then that means $5 of interest for every $100 each year, right? Okay. Next, the time. Next, time. Time in years. We use T. We will usually measure time in years. So usually measure time in years, right? Okay, next, let's move forward. So the next term is convention period. The convention period here. The convention period which we use to denote the lowercase letter m number of compounding periods in each year. Number of compounding periods each year, right? So we will discuss more about the convention period within the latter part of today's lecture, because we have to discuss more information before go through the convention periods later, right? Okay, then let's begin. Okay, if I invest $1,000, which quantity is the principal? If I invest $1,000, if I invest $1,000, which quantity? Is the principal. The principal is the amount borrowed or deposited. So the answer should be $1,000. $1,000. Okay, as I mentioned you earlier, the interest, there are two types of interest. The first one is simple interest. Second one, we are going to talk about the compound interest. Right? So we already discussed all the necessary parts. Let's begin with the simple interest then. The simple interest right? Simple interest is the easiest type of interest to calculate. So with simple interest, interest is calculated only on the original principal amount. So note, with simple interest, the interest is calculated only on the original principal amount. So that means the interest earned each year is exactly the same. That means the interest earned each year is exactly the same. Every year you earned the same amount of interest. So the formula I equals P times R times T, where I is the interest, the simple interest, P principal amount, R annual interest rate, T time in years, right? So the formula says I equals P times R times T, where P is the principal amount, R is the annual interest rate, and T is the time in years. Then we can write the accumulated amount, the entire amount after earn this interest. So the accumulated amount A equals the principal amount, the original amount plus the earned interest. Accumulated amount equals principal amount plus the earned interest. Or we can modify this as A equals P plus. Now we can substitute I, P, R, T and take the common factor P out, 1 plus R, T. Both A equals P plus I and A equals P times 1 plus R, T, or A equals P plus P, R, T gives the accumulated amount. Right? Okay. Let's move forward. The example. Suppose you invest $1,000 at 5% interest rate for 3 years. So let's see the important details. You invest $1,000. So the principal amount is $1,000 at 5% interest rate. So the 5% means $5 per every $100. Therefore, the rate 0.05. And time in years 3. Then let's solve this together. First, identify the information. The principal amount P equals 1,000. Interest rate R 0.05. The time in years T. Now substitute into the formula. Substitute into the formula. I equals P times R times T. So the P 1000, R 0.05, T 3. So the interest, the simple interest, or you earn $150. So the invest earns $150 of interest. Now compute the accumulated amount. A. The accumulated amount is P plus I, the principal amount $1,000 plus interest earned $150. So $1,150 accumulated amount. So notice that the interest was calculated only from the original amount P $1,000. The earned interest 150, accumulated amount both principal and the earned interest 1,150. Okay, let's make a note. The interest was calculated only from the original amount of $1,000. Okay. Let's see one more example. Suppose you borrow $5,000 at 4% annual interest rate for 5 years. For 5 years. Okay, first think about the informations given in the problem. Then we can work it together. Think about, suppose you borrow $5,000 at 4% for 5 years. So we have the original amount $5,000, interest rate are 4%, that means 0.04, and the T, time in years 5. Then let's work together. So I equals P times R times T. P equals 5,000, R equals 0.04, T equals 5. $1,000. The interest should be $1,000. Then total repayment that means the accumulated amount P plus I, 5,000 plus 1,000, $6,000. Notice that whether we borrow money or invest money, the mathematics is exactly the same. Okay. Right? So then let's use this same formula to find out the time. Next example, the example 3. Suppose $2,000 grows up to $2,400 at 6% simple interest. Then how long does it take? Okay, so we have principal amount $2,000. It grows up to $2,400 at 6% annual interest rate, but we don't know how long will it take. How long does it take? So let's use the same formula. I equals P times R times T, and the accumulated amount P times 1 plus RT, because we wanted to find out the T with given accumulated amount A 2,400, principal amount 2,000, and R 0.06. Then let's substitute the values. 2,400, 2,000, 1 plus 0.060. Then solve step by step. Okay, pause the video and solve it by yourself. Okay, so please practice and take your time to practice and solve it for time. The time would be 3 years and 1/3 year, that means 3 years and 4 months. Okay, so far interest has always been calculated using only the original principal amount. But that's not how most banks actually work. Banks usually use compound interest. So let's see the compound interest then. What does the word compound means? The compound interest means interest on interest. Right? So each time interest is added, future interest is calculated using the new balance. So that is each time interest is added, future interest is calculated using the new balance. Okay, so let's see the quick comparison. Here, the simple interest. $1,000, 1,050, 1,001, 1,100, 1,150. Every year you can see that the interest grown by 50, some fixed amount, 50, right? So, but the compound interest start in 1,000, the principal amount, then 1050, the first year 50, second, then afterward 1102 and 50. That means 52.5. So next 1157 and 63. Got it? So 55.13. So you can immediately see the difference. So within the simple interest, each year you earn the fixed amount of interest, but for the compound interest, you earn interest on interest. Okay. Then let's see the compound interest formula and identify the terms. The compound interest formula here A equals P times 1 plus R over M to the power MT. So let's explain every symbol here. Again, A, accumulated amount, at the end of the time period. So the total amount at the end of the time period. P, principal amount or original investment. R, as same as the simple interest, annual interest rate. T, time in years. The new symbol is M. So here M is the number of compounding periods per year. So we discussed at the beginning convention period. So the number of compounding periods in each year, also known as the convention period. M, number of compounding periods each year. Also we called it conventional period. Okay, so let's see how to describe the number of compounding periods each year. M. If the number of compounding period, if the number of compounding period says annually, then M equals 1. One time per year. Then semi-annually, M equals 2, twice per year. Quarterly, quarter means 3 months of time period, therefore M equals 4. Next, monthly, M equals 12. There are 12 months per year. Weekly, there are 52 weeks, then M equals 52. Finally, daily. How many days? 365 in general. Okay, so then MT means total number of compounding periods. Total number of compounding periods. So we say that N equals M times T. N equals M times T. Also, we define I equals R over M for further calculations. Okay, that means we have the accumulated amount P times 1 plus R over M to the power MT. Also, we can rewrite it as A equals P times 1 plus I to the power N. Right? Okay, then let's see the example. Example 1 and the compound interest. You deposit $10,000 at 3% annual interest compounded monthly. For 10 years. So then let's identify each quantity we discussed earlier. So here the principal amount is the original amount $10,000 or the annual interest rate 3%, that means 0.03. So compounded monthly, therefore M equals 12. Time T equals 10 in years. Then let's substitute everything and calculate step by step for the final answer. So here we have A equals P times 1 plus R over M to the power MT. Let's substitute the values then. P 10,000 times 1 plus 0.03 M 12 times T. So you can use your calculators. 12 plus 0.03 over 12, 120. Please make sure to identify that step-by-step solution. So at the end, you will get $13,493.05, 50 cents, right? Okay, this would be the accumulated amount. If we wanted to calculate the total interest you earned, so that is A equals P plus I, then A minus P gives us the total interest. The total interest, 13,493.5 minus 10,000. During the time of 10 years of time, compounded monthly, you earned the total interest amount $3,493.50. 50 cents. Okay, let's move forward for the one more example. Example, Lex has 1,780 and 80 cents. After 6 years, earning 6.8% compounded annually. Find the original deposit amount. Find the original deposit amount. Okay. This problem is different because the final amount is known. Now we are solving for P, right? So that is, we are solving for the principal amount P. So let's see, then using the formula, A equals P times 1 plus R over M to the power MT, then isolate P equals 1 plus R over M to the power MT over A. Let's substitute. I think it is easy to substitute into this formula. Let's find R over M first. Before that, the information given here, A equals 1,780, and after 6 years, T equals 6, earning 6.8, 0.068 R. Compounded annually, M equals 1. Right, then let's substitute all these values. P equals, before that, R over M, we know that R 0.068, M equals 1. Then 0.68. M times T, 1 times 6, 6. Okay, then P equals 1 plus R over M to the power MT over A. P equals 1 plus 0.068 to the power MT over A, 1,780 and 80 cents. So you can easily find out the principal amount before calculate this. Oh, we did wrong. Right? We did wrong. So let's move forward again. It should be isolate P. Right? So that means 1 plus r over m to the power mto. Here a over this. P equals a 1780.80 over 1 plus 0.068 to the power 6. P equals 1.068 to the power 6. So P equals over 1.48397. So the principal amount would be 1780.8 divided by 1.48397. 1,202, approximately $1,200. So the principal amount $1,200. Okay, I will give you the extra practice problem here. The extra practice exercise: suppose you invest $500 for 2 years at 6% compounded monthly. So pause the video and solve it by yourself. Then what changes if interest is compounded weekly? So you should notice that M changes. So, okay, then let's summarize today's lesson. Today we learned the difference between simple interest and compound interest. We introduced important financial vocabulary: calculated interest earned, determine accumulated amount, and solve several investment and loan problems. The key idea to remember is this: the simple interest is calculated only on the original principal amount, and the compound interest is calculated on both the principal and previously earned interest. The next lecture, we will continue with continuous compounding, effective interest rate, and present value, which are widely used in banking, investing, and financial planning. So please make sure to practice all examples and the exercises given in the note. Okay, thank you for watching, and I'll see you in the next lecture.